Welcome to video 9.4c. I've got one more application of the Pythagorean theorem, and then we're going to classify a triangle based on the side length. So first we'll do one more application. All right, example 5. And this one is guaranteed to be in a quiz or a test. It's just a classic problem. Find the altitude of an isosceles trapezoid whose sides are 10, 30, 10, and 20. So right away, you know that the legs are 10. And then the bases would be 30 and 20. So let's start by drawing one. For isosceles trapezoids, what I do is I draw the bases first. And what I do is I center the base. That way I'm assured to get the legs to be somewhat congruent. So that's congruent to that. So now I'll label. We've got a 10, a 10, a 30, going all the way across, and a 20. And what I'm trying to do is find the altitude. I'll actually draw both of them. So I'm trying to find the altitude. Okay, so one thing you want to note is with an isosceles trapezoid, we have symmetry going on. So if I'm 20 there, just let's concern ourselves with this red rectangle here, then I'm going to be 20 down here. And then, if I'm a total of 30 and I'm already 20, I've got 10 to divide up evenly here, so I'm going to be 5 here and 5 here. So 5 here and 5 here. So that's the key to this problem, is that drawing. All right. Now I simply have a right triangle. I'll call this X. Note that this is the hypotenuse, this is a leg, this is a leg. So now I'm just using the Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared. X squared plus 25 equals 100. X squared equals 75. X equals the square root of 75. Again, I will not do plus or minus. I can't have a negative length. And then you always want to simplify that. So that's the same as the square root of 25 times the square root of 3. And the square root of 25 is just 5. So equals 5 radical 3. And they wanted the altitude, so I'll just write in words. The altitude is 5 square root of 3. And they did not give me any units. Okay, again, a classic problem. All right, now shifting gears. Classifying a triangle based on side lengths. Okay, so I do it a little bit differently in your notes, so if you want to cross out your notes a little bit and mark them up this way, I think this is much easier to remember. All right, we've got 3 different scenarios. C squared equals A squared plus B squared. And again, C is going to be the longest side of the triangle. For a right triangle, the hypotenuse, for there is just the longest side. So if C squared equals A squared plus B squared, well then we get a right triangle. That's basically the converse of the Pythagorean theorem. And equals 90 degrees is how I remember that. Now if C squared is greater than A squared plus B squared, I've got an obtuse triangle. And I think of greater than 90, obtuse. And it makes sense if you look at the picture. If C is so long, then it's going to have to be obtuse in order for the ends to make that triangle happen. So again, this angle is bigger than 90, and it follows from the C squared being greater than. The third scenario, C squared is less than A squared plus B squared. All right, when I see less than, that's going to end up in an acute triangle. I think of less than 90 degrees, which is what an acute triangle is. So again, here the C is short enough where we don't have to stretch out to get to that long end, and we have a shorter than, or a smaller than 90 degree angle. So these are the only 3 things you got to remember. This one you already know, so these are the only 2 new things. Okay, so note, I put C squared first, unlike your notes, and C is always the longest side of the triangle. All right, so here's the application. Classify this triangle right here. Okay, it's got side lengths of 8, 7, and 5. Well, the most important thing is to find the longest side. So I'm just going to I'm just going to arrange the sides, small, medium, and large. So the small is 5, the medium is 7, and the large is 8. And I circle that. 8 is that thing that's going to stand by itself on the left-hand side. So now all I'm saying is, how does 8 squared compare to 5 squared plus 7 squared? Is it equal to, greater than, or less than? All right, so I'm just going to work that out. I'm kind of running out of room, so I'll erase over here. So now it's going to be, how does 64 compare to 25 plus 49? How does 64 compare to, what do we have here? 74. Well, 64 is less than 74. So then when I see that less than sign, I think of less than 90, and I think of acute. So the answer to my problem is, it's an acute triangle. Again, on a quiz or homework or test, don't just guess. We need to see that, and we need to see the work. Okay, so there you have it. An application of the Pythagorean theorem, and then classifying a triangle based on side lengths.